Hey, Prob-Stats students, Mr. Mitchell here. We're going to take a look at section 4.3, which is continuing of the least squares regression line. But now we're going to talk about the correlation coefficient and the coefficient of determination. It's R and R squared. So we're going to talk about finding it by hand and also finding it with the calculator. We'll start with the calculator method. So basically what we're trying to do before we get into that, we're trying to decide whether we have a positive correlation, negative correlation, or no correlation. So if you were to plot your dots, your points, and you can draw a line with a positive slope, that's a positive correlation. If you plot your data and it looks like you could draw a line that has a negative slope, that's a negative correlation. If you have dots all over the place, there's little or no correlation. Okay, so here's some examples of no correlations, perfect correlation, and strong correlations. No correlation, where do you draw the line here? Can you draw it here? Can you draw it here? I don't know where to draw it. That means there's no correlation or little, very little, or no. 0 is no correlation. 1 or -1 is perfect. That doesn't usually happen. The only time that happens is in algebra class, because you're plotting points that make the line. But very rarely in stats do you get a perfect correlation of 1 or -1. But again, notice that 1 is positive slope, -1 is a negative slope. So then if you notice these points are fairly close, you can draw a line that represents them. This is going to be a positive correlation, and it's going to be fairly close to 1. So it could be an R value of like 0.7 or 0.8, maybe 0.6, depending. And then this one, points are all close to the line. It's a negative slope, so it's a negative correlation. Somewhere between -1 and 0, I would guess that this is closer to -1, like -0.9 or -0.8, -0.7, something like that. So it's kind of what we're trying to do. Not only are we trying to draw the line, we have to make a scatter plot, and we got to draw the line, and then we got to say whether our line is a good representation of our data or not a good representation. So we have some more formulas. If you remember from last class, we did the slope and the y-intercept, so we need to find SSXY, SSX, and SSY. We already found SSX and SSXY. We need to find SSY. Here's your formulas again. We'll get back to doing it by hand here in a minute. But let's go to the calculator and let's type in our data. I already have mine typed in from before, so mine's in L5 and L6. Again, we're still talking about the root depth of a watermelon plant and the mean weight of the watermelons off of that plant. So once we have our data typed in, we would go to Stat, Calc. Now, if we're just using the calculator to get our final answer, we would do linreg. Type in L5, L6, because that's my X and my Y, and then we're going to calculate that. And there you go. There's my R squared. First, there's my y-intercept, there's my slope. My R and R squared come up. Now, you might be saying, well, I just did that on my calculator, and that doesn't work. Well, sometimes you have to tell it to turn these on. So to turn those on, you go to second catalog, and then you need to define diagnostic on. So you should only have to do this once if you have your own calculator. Now, if you're using a calculator that's borrowed and you get a different one every day, well, then you're going to have to do this every day that we do this. Diagnostic on, turn it on. Now, for me, I already had my diagnostic on, so it's not going to change anything. But if your diagnostic was not on, go back in and run the linreg again, and your R and R squared should show up now. Okay? So looking at the correlation of 0.9, that's a pretty good correlation. So that's a strong, positive, linear correlation. So that's kind of what we're doing. Trying to find whether it's a good fit or not so good fit for our data. And then to find R squared, yeah, our calculator finds R squared for us. R squared is the coefficient of determination. What does it mean? It's the percent measure and variation in in Y that can be explained by the least squares regression line in X. So that's kind of a definition. It's explaining the variation of Y explained by X. Is the best way to interpret that. So we need to know how to find R squared if we have R, and go from there. So one other note, correlation does not mean causation. I'm going to pull that up here in a second and talk about that. But here's some other examples of R values. So there's a -1 and a +1. They're perfect. They're lines. There's a 0.8. Notice those points are pretty close to a line if we drew it. The -0.7. It's pretty close. It's a negative. This one, very, very close. It's not a horizontal line, but it's still fading away this way. So we just need to be aware of that. Okay? So now let's take a look at finding it by hand. So I'm not going to recreate the wheel here. I already found some of this information from before. So we already found SSXY, and we already found SSX. So I can get that. So SSXY from before is 336.4, and then SSX is 579.7. So now we need to find SSY. So we have our formula here, SSY. So to do that calculation, here's your formula again. This found from the calculator, or we could do that by hand as well. This number found from the calculator, or doing it by hand as well. Plug those numbers in, and you get SSY is 240.4. SSY 240.4. So now we need to find R. So we do SSXY, which is 336.4, divided by the square root of 579.4 times 240.4. So we need to type that in our calculator. 336.4 divided by the square root of 579.7 times 240.4. There we go. And hit enter. That's what our R value was before. So 0.9011. R 9011. So our R value. And then we can always find R squared. Go back to the calculator. Take 0.9011 and square it. 0.8119. There's our R and our R squared. So that's how you do it by hand. Last thing that we just want to talk about, there's another slide here. It mentions correlation does not mean causation. A little website to help demonstrate that. So here's two variables. The amount that the U.S. spends on spending on science, space, and technology, so the amount that is spent in the United States, and then the number of suicides. So the more money we spend on science, the more suicides. You can see it's definitely a correlation, but why? Well, there's got to be some other lurking variables here. So it's not causation. Spending more money does not cause more hanging suicides. So that's what I mean by causation. There's a correlation because of other things that are occurring. Okay. These are some of my favorites. Number of people who drown by falling into a pool, and then the number of films Nicolas Cage has appeared in. So you can see there is a correlation. The more films he's in, the more drownings there are. So are we saying that people watch films and then go drown in a pool? I don't think so. I don't think that's what's being said here. What we're saying is that there's a correlation, pretty high correlation, 0.66. But it's not a cause and effect. To do a cause and effect, you need to have an experiment done or random sampling that things have been randomly assigned, and then you can track certain things that way. But this isn't. This is just how many drownings happen in a year, how many films was Nicolas Cage in, and there's definitely a correlation. You can see it tracks pretty close. Goes up and down. This one's good too. Number of people who died by becoming tangled in their bed sheets versus per capita cheese consumption. So the more cheese consumed, the more likely you are to die in your own bed in your own sheets. I don't think that's a cause and effect, but there's definitely a correlation. So as one increases, the other one increases. There's other lurking variables here, and some of them may not be able to be explained. So, the divorce rate in Maine and the per capita consumption of margarine. So, if you don't want to get divorced, don't eat margarine, right? No, that's not. There's other lurking variables here that it could be in play. How about the fact that maybe people aren't getting married as much? The fact that maybe margarine is becoming less thought of as healthy. So there's some other lurking variables here. So you can see there's a whole bunch of other ones. There's age of Miss America, and then murders by steam, hot vapors, and hot objects. We're not just talking about murders. It's by a certain type of murder. You can see it trends as the age changes in Miss America, so do the number of murders. So it's kind of weird to think about, but yeah. Again, correlation does not mean causation. It's not cause and effect, there's just a correlation. If you have any questions, let me know.